second of the continuous ones, the triangular distribution. This is new in that we don't cover it in year 12, and it comes up every year, so it's one to latch onto. The situation where we would use it is quite specific. We're in continuous, so we're looking for a measurement, and we're given two pieces of information. We're given the range of possible measurements and the most likely value, which could be referred to as the mode. And so the probability equals area. In this situation, the probability is represented by a triangle, with the apex of the triangle being at that most common, most likely value, and diminishing from there to a point where it comes to nothing at either end of the range. The triangles don't need to be symmetrical, but they could be, and then the triangular would look quite similar to a normal distribution. So if we stick with the same idea, if we're talking about weight and time for a taxi, and this time the range runs from 2 to 14 minutes, the most common waiting time, however, is 7 minutes. So we've got a triangle, and you would sketch it roughly. 2 to 14, we've got the apex at 7, it's not quite symmetrical, so although this isn't to scale, it shows that roughly. X stands for the length of weight, and the capital X stands for the distribution of all possible lengths of weight between, and I've got the A, B, C's and little x's there. That'll make more sense when we see the formula. The total area for triangle hasn't changed. It's half base times height, but it's also 1 because it's covering all probabilities. So we can therefore use that the area is always 1. So what changes is the base and the height. But when you multiply them together and halve them, it always equals 1. So we can work out. So here we want to find the probability of a wait being under 7 minutes. Well, 7 happens to be the mode, and it's quite common that it comes up this way. So it's the orange area of the triangle. To work out that area, we need to know the height. We know the base, 2 to 7 is 5, so that's not a problem. But we need to know the height. So first of all, we're going to use the idea that we know, so that where the height is 7 is the maximum, so 1 times half, which is for a triangle formula, times 12, which is the range, times the height. So we simplify that and we get the height to be 1/6. So the maximum height of the triangle is 1/6. Now that's also the height we need for this probability, because the answer to this probability question is the area of that triangle. We've got a formula that finds the maximum height of the triangle, and this introduced the B's and the A's. This is on the formula sheet. You can go 2 divided by 14 minus 2. So 2 divided by 12 is equal to 1/6. So that would get us the 1/6 another way. Now we find the area, and it's always tempting because these heights look like probabilities. It's tempting to stop there, but always the answer is the area of a triangle. So probability x is less than or equal to 7 is equal to the area of the orange triangle, and is equal to half times 5, which is the base length, times the height of 1/6, and that's 5/12. The second sort of question, find the probability of wait is longer than 10 minutes. Now the situation has changed slightly in that we don't know the height for this. We know it's less than 1/6 because 1/6 is the apex. So there's a couple of different ways that different people do this, but I'll stick with what they do on the formula sheet. On the formula sheet they have this bit of information. It's just a screenshot. To translate it, the job of this is to give us the heights. F of x stands for y, which is the height if you're working on the Cartesian plane. So the formula comes in two forms. They don't look very helpful, but actually it's quite easy to use. When the height that we're looking for is lower than the mode, we use the top one, and that's when x is between a and c. Now, x in our case is between c and b, so we're going to use the second one. And this formula here, it uses similar triangles. It's not the only way to do it, but it works. Will give us the height. It won't give us the probability. We'll have to use half times base times height always to find the final answer. So in our example, A is 2, C is 7, B is 14, and X is 10 because we want to know the height exactly at 10. We sub that faithfully in. Remember, brackets come before multiplication, so we get it simplified and we get the height is 2 over 21. So the probability is always equal to the area of the triangle, which is always equal to half times base times height. Now, half is always half. The base in this case is the distance between 10 and 14, so that's just 4. And the height, we've gone to quite a bit of trouble to work out, 2 over 21. Multiply them all together, and we get the probability of the wait being longer than 10 minutes is 4 over 21, or 0.19. Or maybe you've gone, should have rounded a little less on that. Okay.